Hello everyone. In this video, we are going to discuss about the superposition theorem. This is the part 2 video. In part 1, we have solved the simple problems. In part 2, we are going to discuss about solving the problem using 3 voltage sources as well as the dependent voltage sources. Okay. So first we'll solve this problem. So the question is compute the current through 8 ohms resistor using superposition theorem for the circuit shown below. Okay. So this is a given circuit. Here we have 3 voltage sources. So 2 15 volt source and 1 25 volt source. Here 5 ohms, 10 ohms, and here also again 5 ohms and 10 ohms resistor. And here again 8 ohms and 10 ohms. So now we are going to find out the current flowing through this 8 ohm resistor. Okay. For that we are going to assume the current flowing through this 8 ohms resistor in the downward direction. So let I be the current flowing through this 8 ohms resistor in the downward direction. Okay. So for solving this problem, what we have to do is first we have to find out the current flowing through this 8 ohms resistor with only one source at a time. Okay. So first if we are considering 15 volt source, then the other two sources should be made 0. If it is a voltage source, it should be short circuited, and if it is a current source, it should be open circuited. Okay. So here the other two sources are voltage sources, so we have to short circuit the other two sources in case 1. Okay. So first we'll solve this case 1. Okay, we are keeping this 51 volt source as such, and we are short circuiting the other two sources. Okay, the other components in the circuit will remain the same. So now we are assuming the current flowing in the downward direction. Let this be I suffix 1. So since it is case 1, we are assuming it as I suffix 1. Here we are considering only the 15 volt source. Okay. So we have two meshes. So we have to consider two currents flowing in the clockwise direction. Okay, for solving this. So let I1 and I2 be the two currents in the mesh 1 and mesh 2. Okay. So if we write mesh 1 equation, we have to write the voltage rise as well as voltage drops. The voltage rise is always written with respect to the voltage source. If the assumed direction of the current is from negative to positive, okay, like this, then this voltage source value is considered as voltage rise. Okay. Otherwise, suppose if the direction of current is from positive to negative, so likewise in the opposite direction, then it is considered as voltage drop. Then the voltages across the resistors are considered as voltage drops. Okay. So now we have to write the voltage rise is equal to 15 in this case. Again, voltage drops. Okay, we have to add all the voltage drops. So now voltage drop across this 5 ohms resistor. Okay. So the voltage drop across this 5 ohms resistor is written by using Ohm's law. V is equal to I into R. Here I is the current flowing through this 5 ohms resistor. That is I1. We have considered it as I1. So by Ohm's law, 5 into I1 is the voltage drop across 5 ohms resistor. So next we have to write the voltage drop for 8 ohms resistor. This 8 ohms resistor is lying in between mesh 1 and mesh 2. Okay. So the current can be either I1 minus I2 or I2 minus I1. So while writing for mesh 1, we have to write it as I1 minus I2 irrespective of the direction of this I suffix 1. Okay. We have to write the mesh equation. So first initially we just forget about this I suffix 1. Now consider I1 and I2 in the clockwise directions. Okay. So next for this resistor 5 ohms resistor, the I1 will be the current, and so the voltage drop is 5 into I1. Again for this particular 10 ohms resistor, current is I1 again. So 10 into I1. Okay. So on simplification, we will get, so this one 5I1 plus 8I1 minus 8I2 plus 5I1 plus 10I1. Okay. So by adding all these, we will get 28I1 minus 8I2. Okay. So this is sum of the voltage drops. Now by Kirchhoff's voltage law equation, we know that sum of the voltage drop is equal to sum of the voltage rise in a closed circuit. Okay. So now this can be written as 28I1 minus 8I2 is equal to 50. So this is equation number 1. So next we have to write the equation for mesh 2. Okay. So for mesh 2, We are having only the resistors and we do not have the voltage source or current source. So the voltage rise is written as 0. So now we have to consider the voltage drops across the resistors and add them. Okay, some of the voltage drops. Now the current flowing through this 8 ohms resistor is I1 minus I2 or I2 minus I1 as we have already discussed. So while writing for mesh 1, we have to write it as I2 minus I1. Sorry, while writing for mesh 2, we have to write it as I2 minus I1. While writing for mesh 1, we have written it as I1 minus I2. Now we have to write it as I2 minus I1. Similarly, current flowing through this 10 ohm resistor is I2. And similarly, current flowing through this 10 ohms resistor is also I2. So 10 into I2 plus 10 into I2. So on simplification, we will get, so we have to multiply this one, 8I2 minus 8I1 plus 10I2 plus 10I2. So this will become minus 8I1 plus 28I2. So now the KVL equation for this mesh 2 is minus 8I1 plus 28I2 is equal to 0. So this is second equation. So this can be written in the matrix form. Okay, just we have to write the coefficients of I1 and I2 for equation number 1 in the first row. Again in the second row, we have to write the coefficients for I1 and I2 of the second equation. So multiplied by I1 and I2. I1 and I2 are the unknown values for which we have to find out the values using Cramer's rule. Okay, this is a matrix form. On the right hand side, we have to write the right hand side value 15 and 0. So first we have to find out the delta value. Delta is nothing but the determinant of this resistance matrix. 28 minus 8 minus 8, 28. Okay. So on simplification, the delta value will become 720. Okay. So next we have to find out delta I1. So for finding out delta I1, we have to replace the first column by the right hand side matrix. Okay, first column is plus 28 and minus 8. So that we have to replace it with the right hand side matrix 15 and 0. So left hand side it will remain the same, minus 8. Sorry, the second column will remain the same, minus 8 and 28. So now we have to find out the determinant. So this will be equal to 420. Okay. So next I1 will be equal to delta I1 divided by delta. So 420 divided by 720. So this will be equal to 0.583 ampere. Similarly, we have to find out delta I2. For finding out delta I2, the second column should be replaced by the right hand side matrix. The first column will remain the same. Okay. So this delta I2 will be equal to 120. So I2 will be equal to delta I2 divided by delta. So 120 divided by 720. So this will be equal to 0.1666. Okay. So now we have to find out current in case 1. So now we have assumed the current in case 1 in the downward direction. Okay. So we have already discussed that this 8 ohms resistor is lying in between mesh 1 and mesh 2. So the current can be either I1 minus I2 or I2 minus I1. So now since I1 is in the same direction as that of I suffix 1, we have to write this as I1 minus I2 only. So if the I suffix 1 is in the upward direction, then we have to write it as I2 minus I1. Why? Because then in that case, I2 and I suffix 1 will be in the same direction. So, okay. So whichever the current is in the same direction, from that current we have to subtract the second value. Okay. So here I1 is in the same direction as that of I suffix 1. So we are subtracting I2 from I1. So that is I1 minus I2. So here again I1 is 0.583 and I2 is minus 0.166. So the answer will be equal to 0.417 ampere. So this is the current in case 1. Okay. So this is case 1 current, 0.417 ampere. Okay. Next we'll solve the second case. For second case, we are considering this 15 volt source only. and we have short circuited the other two sources. Okay, always consider only one source at a time and remove all the other sources. So the voltage sources are replaced with the short circuit, and if it is a current source, then we have to replace it with open circuit. So again, the current flowing through this 8 ohms resistor is considered in the downward direction only, because in the first case we have considered it in the downward. So in all the three cases, we have to consider it in the same direction only. So now again in this case also we have two meshes, say I1 and I2. Okay. So we have to write down the two equations. Always assume the mesh currents in clockwise directions. So, okay, this is case 2. So for case 2, mesh 1, here with respect to I1, this voltage source direction is from, the current direction is from positive to negative with respect to this particular voltage source. So if you see here, I1 will be flowing from positive to negative. So this is considered as voltage drop. Okay. So if it is flowing from negative to positive, then it is voltage rise. Otherwise, it will be taken as voltage drop only. So in this case, we do not have any voltage rise. So now we have to add all the voltage drops. So this 15 volt source is a voltage drop, and then voltages across all the resistors are considered as voltage drop only. So we'll start from here, from 10 ohms. So the current flowing through 10 ohms is I1. So voltage drop is 10 into I1. By Ohm's law, V is equal to I into R. For this 5 ohms resistor, the current is again I1 only. So 5 into I1. So next, for this 8 ohms resistor. So this particular 8 ohms resistor is lying in between mesh 1 and mesh 2. So while writing for mesh 1, we have to consider the current as I1 minus I2. While writing for mesh 2, we have to consider this as I2 minus I1. Okay. So why? Because we have assumed these two currents in the clockwise direction. So from mesh 1, it will be flowing downwards. I1 will be flowing downwards through this 8 ohm, and I2 will be flowing in the upward direction. Both the currents are in the opposite directions. So the net current will be either I1 minus I2 or I2 minus I1. Okay. While writing for mesh 1, we have to consider it as I1 minus I2. While for mesh 2, we have to write it as I2 minus I1. So next current through this I1 is again, through this 5 ohms resistor is I1 again. So the drop is 5 into I1. So now some of the voltage drops on simplification will get. So 10 I1 plus 15 plus pi is 15 plus pi 20. 20 plus 8, 28. So 28 I1 minus 8 I2 plus 50. So KVL equation will be sum of the voltage drops is equal to voltage rise. So 28 I1 minus 8 I2 plus 15 equal to 0, or 28 I1 minus 8 I2 equal to minus 50. So let this be equation number 3. Similarly, we have to write the equation for mesh 2. So in mesh 2, the current I2 is from negative to positive. So it is flowing from negative to positive with respect to voltage source. So it is considered as voltage rise. So again, we have to write down the voltage drop across all the resistor. So if we take this 10 ohms resistor, it is 10 into I2. Again, along this resistor, current is I2 again. So 10 into I2. And for 8 ohms resistor, already we have discussed, we have to write it as I2 minus I1. Okay. So now on simplification, we will get minus 8 I1 plus 28 I2. Now the KVL equation will be minus 8I1 plus 28 I2 is equal to 15. So this is equation number 4. So again, we will solve this by using matrix method. Okay, Cramer's rule. So we have to write the coefficients of equation 1 here. And similarly for equation 2, we have to write down the coefficients here. Into I1, I2. So this will be equal to minus 15 and 15. Okay. So now delta value will be the determinant of this resistance matrix 28 minus 8, 28. So this will be equal to 720. Already we have seen this one. So now we have to find out I1 and I2. For that, we have to find out delta I1. So for delta I1, first column is replaced with the right hand side matrix. Second column will remain the same. Okay. So minus 15 minus 8, 15 plus 28. So on finding this value, it will be around minus 300. Now I1 will be equal to delta I1 by delta. So minus 300 divided by 720. This will be equal to minus 0.4167 ampere. Okay. So next we have to find out delta I2. For delta I2, second column should be replaced with the right hand side matrix 15 minus 15, 15. So this value will be equal to plus 300. So now I2 will be equal to delta I2 divided by delta 300 divided by 720. This will be again plus 0.4167 ampere. Now I suffix 2 in this case will be equal to I1 minus I2. Why? Because I1 and I suffix 2 are in the same directions, downward direction through 8 ohms, and I2 is in the opposite direction. So we have to write it as I1 minus I2 only. So I1 is minus 0.4167 and minus of I2 is again plus 0.4167. So on simplification we will get minus 0.833 ampere. So this is current in case 2. Okay. So already we have derived the current in case 1, which is equal to 0.417 ampere. Now the case 2 current is minus 0.833. Okay. So now we have to solve the third case. In third case, what we have to do? We have to make the other two sources 0, keeping only the 25 volt source. Okay. So again we will assume the current in the same downward direction, I suffix 3 this time. And again assume two different currents I1 and I2 flowing in the clockwise directions. Okay, this is case 3. So for case 3 we have to write again the mesh 1 and mesh 2 equations. So in mesh 1 we do not have any voltage source, so we can directly write voltage rise is equal to 0. Okay. So now the voltages across the resistors are written as the voltage drops. So we'll start from 5 ohms resistor. So the voltage drop across 5 ohms resistor is 5 into I1. This 10 ohms resistor is again 10 into I1. This 5 ohms resistor is 5 into I1 plus current through this 8 ohms is written as I1 minus I2 for mesh 1. Okay. So on simplification, we'll get the same equation 28 I1 minus 8 I2. So KVL equation will be 28 I1 minus 8 I2 equal to 0. Okay, this is equation number 5. Okay. So similarly, we'll write the equation for mesh 2. So in mesh 2, the current I2 is flowing from positive to negative with respect to this 25 volt source. So this is considered as voltage drop. So in this case also we do not have voltage rise. So we have to consider this as a voltage drop only. So 25 is the voltage drop. Now we'll find the voltage drop across 10 ohms resistor, this 10 ohm and 8 ohm. So this 10 ohms resistor is 10 into I2. Again this 10 ohms resistor is also 10 into I2. Again this 8 ohms resistor, while writing for mesh 2, we have to write it as I2 minus I1. Okay. So on simplification, we'll get minus 8 I1 plus 28 I2 plus 25. So KVL equation will be minus 8 I1 plus 28 I2 equal to minus 25. So this is equation number 6. So again we'll write this in the matrix form. So we'll write the coefficients here for the first equation, and for the second equation minus 8, 28, and then here I1, I2. On the right hand side 0 minus 25. Okay. So now we have to find out the delta value. So delta value will be the same. Okay, 28 minus 8 minus 8, 28, this will be equal to 720 So now we'll find delta I1. For finding delta I1, replace the first column with the right hand side matrix. So minus 8, 28. So on simplification, delta I1 will be equal to minus 200. So now I1 is equal to delta I1 divided by delta. So minus 200 divided by 720, which will be equal to minus 0.278 ampere. So next delta I2 will be equal to, first column will remain the same, 28 minus 8. Second column is replaced with the right hand side matrix sum. So on simplification, this will become minus 700. So I2 will be equal to delta I2 divided by delta, which is equal to minus 700 divided by 720. Okay. So this comes around minus 0.972 ampere. Now the current in third case. So this third I suffix 3 will be again I1 minus I2 only, because I1 and I suffix 3 are in the same directions. Okay. And I2 is in the opposite direction. So we have to subtract I2 from I1. So I1 is minus 0.278. And then minus of I2 is minus 0.972. Okay, this minus and minus will become plus. So on simplification, we will get 0.694 ampere. So this is current in third case. Okay. So now for finding out the current, total current flowing through this 8 ohms resistor, we have to add all these three. So I suffix 1 plus I suffix 2 plus I suffix 3. So I suffix 1 we have already derived, which is nothing but 0.417. And then I suffix 2 is minus 0.833. And I suffix 3 is 0.694. Okay. So adding all these things, that is 0.417 minus 0.833 plus 0.694. Okay. So we will get 0.278 ampere. So this is the answer. So next we'll solve another problem. The question is, determine the current Ix in the circuit using superposition theorem. So this is a given circuit. Here again we have three sources. One is a 10 volts source, which is a voltage source. And here we have one current source. And here we have another voltage source, but this is a dependent source. Okay, this is a current dependent voltage source. Okay. So the procedure is, we should not open circuit or short circuit the dependent source. We have to keep it as such, and we have to consider the other two independent sources and to proceed with the same procedure. Okay. So we have to consider these two sources only. First we have to find out current flowing through this 2 ohms resistor, that is I suffix x, using 10 volt source only. Okay. So next we have to find out using 3 ampere source. So first we'll keep this as such, and we will open circuit this. If it is a current source, we have to open circuit. So we will open circuit this one and we will proceed. Okay. So in case 1, we are considering Ix as Ix suffix 1. Okay, this is case 1. So we are going to find out the current through 2 ohms resistor using 10 volt source. Okay. So the other 3 ampere sources open circuited. So now we have only one loop with 2 sources. Okay, and 2 resistors. So we will consider one current I flowing in the clockwise direction. Always assume the loop currents in clockwise directions only. So now we have to write down the Kirchhoff's voltage law. So here if you see here, the current I is flowing from negative to positive with respect to this voltage source. So this is considered as a voltage rise. Okay. So if you see this source, the current direction will be in the downward direction, that is from positive to negative. So this source is considered as a voltage drop. Okay, next voltages across the resistors are considered as drops only. So first we'll find out the voltage drop across 2 ohms resistor. So 2 into I plus 1 voltage drop across 1 ohm resistor, 1 into I, or simply I, plus 2 into Ix suffix 1. Okay. So in this case, Ix suffix 1 and this assumed current I, both are in the same directions. So Ix suffix 1. So here Ix suffix 1 is equal to I. Okay. So both are same. So we can substitute I over here. So on substituting I here, we get 2I plus 2I. So this will be 5I. So now by applying Kirchhoff's voltage law, so we can write sum of the voltage rise is equal to sum of the voltage drops. So 5I is equal to 10. I is equal to 10 by 5, which is nothing but 2 ampere. So this is the answer for case 1. So now we have to find out case 2. Okay. So in case 2, we are considering the 3 ampere source. Okay, this is with the 3 ampere source only. So the other source, 10 volt source, is short circuited. Okay. So if it is a current source, we have to open circuit it. In the previous case, we have open circuited this one. In the second case, since it is a voltage source, we have to short circuit this. So here again, we are considering the current as Ix suffix 2. So here also we will consider the same notation. Okay. So here we have 2 loops. So in the previous case, we were having only one loop. So we have assumed one current in the clockwise direction. Whereas here we have 2 loops. So we have to assume 2 currents, I1 and I2, flowing in the clockwise direction. Okay, always assume the currents in the clockwise direction. Okay. So now if you see here, this I1 and this Ix suffix 2 are in the same directions, right? So this Ix suffix 2 can be written as I1. Okay, let this be one equation. Okay. So now this in between mesh 1 and mesh 2, we have 3 ampere current source. So it is considered as a super mesh. Okay. So if there is a current source present in between 2 meshes, we should write the super mesh equation. Okay. In that case, what we have to do, initially we have to ignore this branch. Okay, while writing the equation, we should not consider this branch, but we have to consider these 2 currents and write only one equation. Okay. So after writing one equation, we have to equate the current flowing through this branch to the current source. Okay. So now initially we will ignore this one and we will write one equation. Okay. So here we do not have voltage source. Here we have one voltage source. This is current dependent voltage source only. So the current direction I2, we have assumed it to be flowing from positive to negative. So this is considered as voltage drop. So in this case, we do not have voltage rise. So now we have to write down the voltage drops. So if you see here, current flowing through this 2 ohms resistor is I1. Okay, because it is present in mesh 1. So the voltage drop is 2 into I1. Similarly, current flowing through this 1 ohm resistor is I2. So this 1 ohm is present in mesh 2. So we have to write it as 1 into I2 or simply I2, and this 2 Ix suffix 2 is the voltage drop. Okay. So Ix suffix 2 is nothing but I1. So we will substitute here. So sum of the voltage drop will become 2I1 plus I2 plus 2 into I1. So on simplification, we will get 4I1 plus I2. Now by Kirchhoff's voltage law, sum of the voltage rise is equal to sum of the voltage drops. So 4I1 plus I2 will be equal to 0. So this is second equation. Okay. So now what we have to do is, we have to equate this branch current to the current source value. Okay. So now we have 2 different currents, I1 and I2, both are assumed in the clockwise direction. Whereas the direction of the current source is in the upward direction. Okay. So we all know that suppose this is the branch AB, the current flowing through, since this branch is present in between mesh 1 and mesh 2, the current flowing through this branch can be written as either I1 minus I2 or I2 minus I1. Okay. So now if the current source is given, okay, that too in the direction of I2. So this I2, if you see here, this I2 and the current source directions are same. So in that case, what we have to do is, we have to subtract I1 from I2. I2 minus I1 is equal to 0. So let this be equation number 3. Okay. Suppose if the current direction is given in the opposite direction, okay, in the downward direction. Suppose the current is flowing from A to B. In that case, what we have to write? I1 minus I2, because the current direction and I1 are in the same direction. Current source direction and I1 direction are in the same. Okay. Similarly, in this case, we have I2 is in the same direction as that of the current source. So, we have to write I2 minus I1 and equating it to 3 ampere. Sorry, here we'll get 3. Okay. So, now we will add these two equations. Okay, we can add 2 and 3 and we'll find out I1 because I1 is nothing but Ix suffix 2. Okay, we have to find out I1 here. So, we'll rearrange this equation. Okay. So, first I'll write the second equation 4I1 plus I2 equal to 0. So, now the third equation is minus I1 plus I2 equal to 3. Okay. So, now we will subtract these two equations. Okay, not adding these two. We'll subtract these two equations. So, we have to change the sign over here. So, this I2 will get cancelled and this is 5I1 equal to 3. Okay. Minus 3. So, I1 will be equal to minus 3 divided by 5. This is equal to minus 0.6 ampere. This is I1, which is Ix suffix 2. Okay, from equation 1, we know that I1 is equal to Ix suffix 2, which is equal to minus 0.6 amperes. Okay. So, now we have to find out Ix value. Ix is nothing but Ix suffix 1 plus Ix suffix 2. Okay. So, Ix suffix 1 already we have found out. Ix suffix 1 is nothing but 2 ampere. Okay. Ix suffix 1 is equal to I, which is nothing but 2 ampere. And then in the second case, it is minus 0.6 ampere. So, we have to add both these together. So, 2 minus 0.6. So, which is equal to 1.4 ampere. So, this is the answer.